Hello student, welcome to our physics discussion, that is physics in a smart way. So today we are going to consider a question that is, it can be present in, in, rotas, in rotational motion, also that has got link with work, energy and power. So this is an interdisciplinary issue. It's a question only. So as the question is there, we got a hemispherical surface, the inside of a hemispherical ball. And if you go to the question word by word, it says a small block of mass m starts to slide down from the position A. Position A is the start. Inside a smooth hemisphere as shown in the diagram. Find the time it takes to get to the bottom. So as you got the question, the block starts to slide from position A, and slowly as it goes down, it picks up speed. How much time it does take to go to the bottommost point of its path, that is the position B. The position, all those things, they can be shown in terms of angle. You know, at the starting point, if you consider its instantaneous position by an angle theta, at the starting point, theta equal to 0. At point B, we know theta has become pi by 2 or 90 degree. Okay, so thereby we start to discuss it. But first of all, you must give your video a pause, try to think of the issue, try to think of the situation, and try to analyze it. And if possible, try to find a solution. I am going for the solution. So as it is given, and also I have told you, you can consider this issue as an issue of rotation, but very rarely we find topics or issues in physics which are not connected to other topics. So this is connected with rotation, of course, because the path that the block is taking will be a circular one. At the same time, we are going to utilize our ideas on work energy and try to find a solution. So if you go for the answer, we already know that the block is starting from A. At any time t, which is an interval time, if it has gone to this position where this black dot shows the block as in its instantaneous position, it has already covered an angle theta at the center and has gone down by a distance h. The circle that we are considering has got a radius r. And if you consider this right angle triangle, we know that sine theta will be equal to h by r. Cross multiplying, we got your h equal to, that is r sine theta. This we keep in reserve for our future use. Again, coming back to the diagram, as already we have stated that the block has already gone to this position, that is an intermediate position, and as it starts to slide down from position A, it gradually picks up the speed. So we can either talk in terms of its translational speed or simply that is velocity or speed v. If somebody talks from the point of view of rotation, then he or she can talk in terms of angular speed or angular velocity, that is omega. So we are going to utilize both ways. Because the body has gone from A to this position, we know in terms of energy, it has already lost a height h. So it has lost a potential energy, which is mgh, which consequently will come out as its kinetic energy in the form of kinetic energy. So if we use the work energy theorem or energy conversion, we know loss of potential energy loss of potential energy will be equal to gain of kinetic energy. Gain of kinetic energy. Loss of potential energy will be equal to, obviously, that is mgh, and gain of kinetic energy, you know very well, that will be equal to your half mv square. Okay, that is energy conversion. Now, putting in the things, substituting things, we know H can be replaced as your r sine theta. So we are replacing H as r sine theta. On the other side will be equal to half mv square. We know the relationship between the linear speed, that is v, and angular speed, that is omega, and everybody knows that v equal to omega into r. I am using the term speed. I am not so interested in the so-called velocity and all those vector aspects and all those things, because those are mostly not required. So if we replace speed v with the help of omega and r, so then v square becomes omega square r square. You may be wondering why omega does come in. What is the requirement of omega? Why you cannot solve with the help of v? No, the thing is that we basically see the motion of the body in terms of not a linear motion, but a rotational one. So if our basic motion is a rotational one, so omega will be more helpful when you compare with v. So thereby v is replaced with the help of omega and r. So if you now cancel the both sides, will be cancelling out, 1r will be cancelling out, and ultimately we got, that is, your omega square will be equal to 2g sine theta divided by r, and finding omega will be equal to square root of 2g sine theta divided by r. Okay, we have come down to this point, but you know our basic objective was to find time. We need more space here, so I am removing the question. Already the question is with you. We need some space here. Sorry, a part of the diagram is gone, but you know that is there with you. So thereby, I don't bother about our loss and all those things. We have to get on with the solution. Now, so far as the omega, the last step is concerned, omega equal to 2g sine theta by r. But we know omega can be expressed as d theta by dt, and cross multiplying, we got, arranging the terms rather, dt equal to d theta by omega. And if I substitute the value of omega, we know that comes out as d theta divided by root over of 2g sine theta, divided by r. Rearranging the terms, we know dt comes out to be, and especially taking the constants, we know that comes out as r by 2g. They are constants, they are taken out, and outside this square, outside these, the things that remains, that is d theta by root over of sine theta. These things are mostly variables. But our job was to find the time. So if our job is to find the time, we know our next thing we must go is for integration. And when you go for integration, we know that the required time t or delta t, which is the integration of dt, and that will be equal to, on the right hand side, you have to do the integration also, r by 2g integration of d theta by root over of sine theta. And the limits of integration, of course, will be, you know, at the start, at the point A, we know theta equal to 0. At the end, when the body gets to the point B, theta equal to 90 degree or pi by 2. We have arrived at this stage. Now, I'll be stopping here. My question will be to you, it will be, can you solve this integration? If it is possible, you try to solve that. Think about the issue, and until unless we solve this integration, we cannot be able to find the value of the time. So now the job that is left to you is to complete the integration. So think about that and see whether it is possible or not in your part. Okay, thank you for today. That is the job. That is the food for thought for you. Let me stop here, and that is